Hey friend, it's Colin from Sonic Scholar. Today we're in the second video of the Data Structures playlist, where it's all about giving you the right tools for the job to organize your app better, code more productively, and make your apps more efficient. The last video was on arrays, and today we'll talk about lists. We're using C#, but if you're from the Java world, you might know the term better as array lists. Just know that C# lists are basically the equivalent of Java array lists, and we're actually going to code up our own simple array list in C#, as well as peek behind the curtain in C# list class to see what's going on. Lists are very useful classes that are like arrays, but they have lots of useful methods for easily adding, inserting, removing items, and unlike an array, you can add items into the array without worrying about whether the item is going to go outside of the bounds. How does it do this? Well, it's really that lists and array lists are just a wrapper class around arrays. Remember in the last video, I said that arrays are the simplest data structures and they're just containers for memory. They really are foundational and they serve as the basis for many other data structures. So the big trick to remember is that the array inside the ArrayList class, when it runs out of room, it does the same thing we talked about in the last video. It allocates a new array that's bigger than copies everything over. Now, the user of a list or array list shouldn't really care how it's implemented underneath, except to the extent that they may need a guarantee on performance. So we'll look at that as well when we code it up. By the way, this idea that a class hides unnecessary implementation details is called abstraction, and it's one of the 4 pillars of object-oriented programming. If you want to go more in depth, I have a premium class with a module in object-oriented programming, and you can also download a free quick reference sheet that I've put together that covers all this material in more detail. Click the link in the description. Okay, let's pop open Visual Studio and get cracking on coding up our array list in C#. All right, so here we are in Visual Studio, and unlike the last video where I just ran everything out of the console, I have all this code from the last video pulled up. I'm actually going to demonstrate this using unit tests. But first what I'm going to do is add a new interface. And why would I add an interface, you might ask? Well, it's going to come in handy for the abstraction principle we mentioned earlier, as well as test-driven development that I can show you here, as well as other implementations that may not use an array as the internal storage. So stay tuned for future videos for that. I'm going to call this iSimpleList, and this interface is going to define what my list can do. I want this list to be able to hold any generic old object, so I'm going to give it a type T parameter. We need a way to add on to our list, so I'll make a add. I do have GitHub Copilot just to help me step out this code a little bit faster. Next, we want a way to return the size of the list, so I'm going to add a property for that. It'll be get only. I'm not going to be able to set this from the outside, just retrieve the current size of the list. Of course, I want to be able to access an item at a given index, so I need an accessor for that. I also want to be able to set it. Coming up with your interface first really forces you to think about what is the actual functionality of the class that you're going to create. So the fact that I've created this first will help me to stub out the actual ArrayList implementation. So I'll do that next. I'm going to go add a new class. I'm going to call it Simple ArrayList. The first thing I'm going to make it do is implement that interface that I just created. So iSimpleList object. Actually, I need to make it generic, and then it'll implement all the methods of that generic interface. Little red squiggly says, hey, you haven't implemented the interface yet. No problem. I can hit Control Dot on it and say implement interface, and now it's stubbed out everything that I need to so far. Now, instead of diving right into the code and implementing this, what I'm going to do is create unit tests first. This is a bonus tip for you because I want to hook you up, but I also want to practice what I preach and just show that test-driven development really does make things better in the long run. So I'm going to add a unit test project. I've I've opted to use NUnit as my test framework. I'm going to change this file name from unit test 1 to simple ArrayList tests. And going back to my simple ArrayList class, there's a few other things that I'm going to expose through this class directly, but not through this interface. We talked about how the ArrayList needs to have a capacity and the array underneath needs to grow. So what I'm going to do is create member variables that are private to this class, which is the array that holds everything. We made an array of type T. We don't know what T is until the user of this class invokes this. I'm also going to want a property that shows the current capacity of the array list underneath. And again, that's for performance reasons. The person using the simple array list may want to say, hey, when I create this guy, here's how many spaces I want you to reserve, because they might know ahead of time how much memory they need. So if they do that, we want to give them the option to allocate exactly the amount of memory they need without having to regrow the array multiple times without them knowing. So what we'll have here is a property for the capacity. I'll just throw not implemented there for now as well. Again, all I'm doing here is just stubbing out what the class is going to look like. And this might not make sense, but you'll see as I make the tests first, you'll see I'm going to design how I want to use this class first, and then I'm going to implement it later. I know I'm going to need a way to construct this list, so we'll take a default constructor, and I want to, let's say, make the default size of the array always 4. Instead of just having a magic number there, I'm going to create a constant default capacity and just reference that. Then I need another constructor that uses the capacity that somebody passes in. So thanks to GitHub Copilot for reading my mind. It knew that I wanted to pass in an integer for the capacity and use that in the allocation of the array instead. I think that's all I need for now just to get this stubbed out. Let's go back to our unit tests. And I've got ReSharper for code coverage. There is a free tool you can use in the extensions called Fine Code Coverage. It works pretty well as well. But what I can do is I can right click on my test project, go down to cover unit tests. That's a ReSharper function once you have that enabled. And then it shows you on the unit test coverage how much of your code is being automatically run by unit tests. So as soon as this is all green, I know I'm going to be good to go, at least for my particular classes that I care about, which is the ArrayList. So what I want to do next is write some tests for my simple ArrayList. I don't want to forget to add the dependency. So here's my tests project, and I'm going to go to add project reference and make sure that it's referencing my other little console app. First thing I'm noticing here in my test page is that I don't see the simple ArrayList class exposed, and I think that's because of this being internal. So there's two ways I think I can fix that. The first one would just be to make this public. 99% of the time, if you're making an API that exposes a data structure, you want that to be public. But there's another way you can do that, where you can make the internals of a particular module visible to another assembly. So I'm going to try to do that. And I was able to do that. I just went to my main program class and I added this directive here, assembly internals visible to. And now let's see if I rerun these tests, if they show up. Look at that. It just popped up in my list. So pro tip there, if you want to keep something internal to a module, you can. But if you want it to be visible to a test, just like it was public, you need that internal visible to attribute. Well, let's first start testing the constructors. Okay, the 3 A's of unit testing: arrange, act, and assert. So first thing is going to spend time arranging, get my list that I needed. Okay, and then I just had this misspelled, so I've corrected that, and now it should be visible from my unit tests. There we go. In this case, my arranging and acting are the same. I'm just creating the list and checking that the capacity is 4. I'll make another test that tests the capacity of a custom thing that was passed in. Again, GitHub Copilot just stubbing that out for me nice and quickly. So we have a new list. We say I want a capacity of 10, and I expect that 10 should be that capacity. Now I'll just try adding an item to the element. And this is stubbing it out for me. Add increases the size by 1. So we have a new list, and we are going to add 1 to the list. And we should make sure that the size is 1. We can also test that the element at index 0 is equal to 1, but we'll do that in the next test for the accessor. There we are. We make another list. We add 1 to it. We check the actual value at index 0 and make sure that it's equal to 1. For the next test, we want to add some items and double check that the internal capacity increases when I go past a certain point. So we're going to initialize it with a capacity of 1. We're going to add 2 items to it. And now we're expecting the capacity to double. So we're going to say that the capacity it was 1. We want it to be 2. Okay, so we could definitely be a little bit more thorough, but this is a good start. So I'm going to just go ahead and build this, and we should see all kinds of errors. So we'll run the cover unit tests, which will build it and run it. And we can see, all right, some of our code coverage is increasing. But if we go look up at the top here in the actual tests, they're all failing. So then what I like to do is just start at the first one that's failing, or just pick one and then start working on it. So of course, it's saying that the method or operation's not implemented. It gives me a stack trace and I can click on it. Conveniently takes me right there. So here's what we're going to start doing now now we get to do the fun stuff. It just took a little bit of time to stub out some unit tests, but now we get to start implementing the class. And all we get to do is rerun these code coverage unit tests. And this is going to give us real-time feedback as to how done we are. So I'm looking for some low-hanging fruit here. So let's do the capacity first. So capacity should be easy. We're just going to take the array, the size of that array, and return that. And since all arrays in C# have a property on them called length, that's essentially what's going to be our capacity. So I'm just going to quickly return the array.length here. And then if I rerun the code coverage, actually with ReSharper, I'm going to turn on auto start tests on build. And so then every time I hit build, Control-Shift-B, it's just going to go ahead and rerun these tests for me, and my code coverage should increase. I might have to run the code coverage manually. But anyway, these two tests are passing. So we'll look at the next one, capacity hitting after max value. So what we want to do is increment the array as we get bigger. So we're gonna have to take this one step at a time here. So we have this array of a certain capacity, but whenever we add enough items into it, it has to grow. So the first thing we need to do is be able to add items into it, and that's what's failing. So why don't we start with that? We have our add method. Here's the item to be thrown in, and all we're gonna do is something like this: take array of some index. We don't know what that is yet. And we're gonna set it equal to the item. So what index do we use here? Well, it seems like every time we add something, we're gonna need an internal tracker that tells us how far into the array that we are. So I'm gonna make a member for that. And it looks like it's suggested a name for me, index. We'll start it at 0, and that works for me. So we'll use this member variable. I like underscores for my member variables, as I talked about in coding conventions videos. Then what we need to do is, after adding something to the array, we increment the next index. So that's actually what we should call this. Maybe it's sort of generic right now. And hit Control R. ReSharper pops up with this dialog, but Visual Studio will have one as well. and it just allows me to rename the symbol in all places. I'm going to call this next add index. So that's the next place that we're going to add in. And now let's go ahead and try to build it, see where we're dying. So let's see, add increases the size by 1. So let's see, the size is not implemented yet. So let's go implement that. So the size is basically the same thing as the next add index, right? If the next index to add is at 0, that means we haven't added anything into it. If we're adding at index 1 next, then that's what the size is. So let's double check that, hit run or hit build again. And look at that, that test is working. And it's great, again, having these unit tests, because I don't have to use my brain to try to double check myself as much, because I have these little test robots doing it for me. Again, I've just defined what I'm expecting here in the test first. So we got another test. Now we want to check to see if the items that we're adding, we can actually pull out. And as I do this, another that thing that I realized is we want a way to set the value at an index, not just add one on to the end, right? So I'm going to add a test there, add item, and change the value at index using accessor. Make my list, add my item, and then I added 1 to the list, but now I'm going to change it to a 2, and then just make sure that 2 is in the list. So that's great. Can always add cases as you think of them. And this is one that I want to check next. So this accessor functionality. Let's go back to the array list. And what we can do for the get is just return the array at the index that was passed in. And for the setter, we can just say that the array at the index that was passed in equals value. Value is a keyword that we have in C#. Now value is an object. I need to change this from being object to a T, because we're using this generic here. And so I miss this in my interface as well. I shouldn't return an object I should return a type T, because we're using generics. If generics are confusing, I go into it in my object-oriented programming module in my premium course. You're welcome to check that out, or again, the free guide in the description. Now I'm going to build again, and let's see if any more of my tests are passing. It looks like they are. And then I just have one more test to work through. So this is capacity increases after hitting the max value. So we've initialized it with a size of 1, or capacity of 1, I should say. We've added 2 items, and something goes wrong, right? It says index was outside of the bounds of the array. Let's go debug into that. I already know what's going on, but just to show you another way that you can use these unit tests to your advantage when something's going wrong. Because it's failing on this test, I just go right in here, right click anywhere inside of this test method, and I say debug unit test, and it's going to load it up for me. Yeah, it was saying that it was failing on this line here. So if I hit F11 to step in, and I can see, okay, I have an array of size 1. Well, I'm going to add something at the index of 1, which doesn't exist. Remember, computer scientists count at 0. So 1 is outside the bounds of the array, and this is giving me the exception. So just another way that you can use tests, especially when you're working with stuff more complicated than this, to debug. So let's go add that functionality. I'm going to just hit stop with the functionality to increase the size of the array. And we need to be checking that here. And in fact, it's almost like I want another method to do that. We could check the size of the array here, but I'd rather have something that says, hey, go check and see if we need to increase the size of the array, and then do it if needed. So I'm going to not make this public. I'm going to make this a private method. And I'm going to name this expand array if needed. And so when do we need to expand the array? Well, if the current size, or if the next index to add is outside of the bounds of the array, then we know we need to increase. So how do we know if that's going to be outside? Well, the next index to add, if that's equal to the size, then again, because we count from 0, that's going to be our case. So if the next index to add equals the current capacity, I keep saying size and capacity, so sorry if that's confusing. In this case, we need to grow the array, so we need to make our new array. We'll make it temp. This is just like our old code in the old demo. So if I go back to our first array demo and I look at expanding the array, remember, we just create a new temp array. In this one, it was using integers. I'm using generics now, but we just, make a temp array and then copy everything over using this little for loop. There's a little bit easier way we can do this in here, but I'll make my new array first. And then we can actually use the array.copy method, saying the source array is my underscore array. The destination is my new array. And I want to copy whatever our capacity is. That's how many elements I want to go over. So just a convenient way, it saves me a line or two instead of having to write a for loop and call that out manually. GitHub Copilot was happy to suggest that for me, but array.copy is an equally viable alternative. Now that we've created the new array, we need to set the member variable array to the new array. And then the old array is going to just get picked up by the garbage collector at some point. Now inside the add method, I can just say expand array if needed and just put that check in there, and I don't have to convolute the rest of the add method with that logic. I can break it all out into logical pieces. Let's go ahead and build that and see if we get more tests passing. Great. Looks like they're all passing, so that's awesome. Okay, now that everything's passing again, I want to rerun my coverage. I kind of wish this would do this automatically for me, but oh, actually it can. So in ReSharper, I can just tell it to auto cover as well. Go ahead and run a build. And now I can see here's my simple ArrayList class of type T. And look, 100% of the lines in that class are all covered. I can see all this nice green here in the margin. That's telling me, yep, a unit test ran this code. And so I have all my coverage there. So really, that's all that's going on with simple ArrayList. And a list in C# or an ArrayList in Java, it's going to have a lot more functions, a lot more methods to let you do stuff like add at certain indices, remove at certain indices, or find items the first thing at a certain index. So we can take a look at that briefly. But again, just ArrayList is a data structure. It wraps an array and creates all this nice encapsulation. And as promised, I said we'd go look at the list class and peek behind the curtain. So let's go do that. I'm just going to go back to a unit test here. I'm going to say delete this, but I just want to make a list of integers just to show you what's going on. So once I have that written down, I just click on list and hit F12 or right click and go to definition. And this just took me again to the .NET source code. And so look, we've got list of T, and tell me what seems familiar. Well, interestingly enough, look at, they have a constant int called default capacity. They always also use 4. That was kind of a coincidence. We've got look at this, a T array of the items. That's all the items. That's a generic list as well. Notice that it's also implementing interfaces. So there are other classes from .NET that use this iList, which is pretty cool. And the interface allows for that. Look at this. We've got a integer that keeps track of the current size. Let's pop down and see what methods we've got here. So I want to look at the if there's an add method or something like it. This list is sorted alphabetically. Here we go. I can say add, and what's going on here? All right, so we have our item, and then actually they are doing this check here. If the size is less than the length of the array, like they increment the size and then they add the item to the array. Otherwise, they have their case add with resize. So they've just done it a little bit differently. A little helper method here. Looks like they just pass the item in. Again, I have no idea why it's written this way. I'm sure that the people at .NET are a lot smarter with performance. Looks like they've got a grow method. Let me hit F12 on that. Look at this is private. So any user of the list class in .NET and C#, you're not going to see this grow method, but it is a private. So that's similar to what I have here, right? I have the expand array if needed. I don't want outside people of this class to use this method, so I've made it private. So they've done something similar here. And let's see what's going on. Okay, we need to calculate how long is our new array going to be. And it says, well, if the current array is size 0, then make it 4. That's the default capacity. Otherwise, double it. Take the current length and double it. So that's kind of similar to what I had as well. And now all I'm seeing here is that there is setting a capacity property. So where I was confused so far is I'm not seeing where they actually copied all the elements, right? So we just had this grow method here. If I go back to the add method, here's add with resize, right? It called grow, and then it just adds the item into the new array. But where does the new array get created and all the items copied over? Well, you have to kind of use your developer intuition a little bit. There's this capacity property, and if I F12 on it, I can see there's a getter and a very custom setter here. So it looks like this is where they're doing that at. As you increase the capacity, it's checking, is the new capacity bigger than what it used to be? If so, or if it's not equal to, here we go. We make the new array the size of value. Value is a keyword for the properties in C#. And looks like they opted to use the array.copy as well. So they have the source array, their items, copy them into the new items, only copy as many items are needed. And then here's the member variable, set it equal to the new items. And so that's where that's happening. So kind of cool. The same way that I had planned to do my simple array list is actually how you see the same concepts here in the .NET code too. Let's maybe go look at that accessor. So we've got this keyword here. Sets or gets the element at a given index. Similar kind of thing here. Looks like there's an extra check to throw an argument out of range. And then we just return the value at the specified index. Similarly, in the set, we say get the item at that index and set it equal to the value. This version variable, I'm not sure what that's for, but maybe that describes how many times the array has been changed over time. Just kind of, again, using my developer intuition to make an educated guess there, but I'm not totally sure. So there we are, kind of an in-depth example for ArrayList, but I wanted to show you some object-oriented stuff, some unit tests, so a bunch of bonus stuff your way. I hope you enjoyed that. Join me on the next video. If you find content like this useful and helpful, do me a favor, hit that thumbs up or hit the subscribe button. Help my tiny little channel grow and reach others. Just appreciate you being here. Again, check out either my premium course or the free guide on object-oriented if you're interested. Go check that out. It's free to you. Thanks for watching. I'll see you in the next video.